That's high, about a little over 2 thou. I think these are the highest ones right there. Just a little over 2.5 thou, and then we're back to 0, my original starting one. Not sure if you guys can see that. So all right, so they're all pretty good except these couple over here, just a couple thou high. Well, hey everybody, it's Tom here. Welcome back to my shop. So this week's video is going to be building an arbor for this carbide insert face mill. So if you saw the intro, I was just kind of checking, make sure it is not trash. Hate to build an arbor and find out that these inserts are all over the place. One 7/8 thou tall, one a couple thou low, and just wouldn't be usable. But it is used, and it is a decent one. 8 inserts, 5 inches across, so should be about just the right size for the boring mill, since it's a 7.5 horse motor. So it should be able to work fairly well. That is not a very fast boring mill. I think the highest speed is 331 RPM, so it won't be flying chips off of it, but it'll still be chewing. So let's get over to the table and let's get started and figure out how to make an arbor. So we got 3 inches across here on this face. Grooves for drive dogs, and then it necks down to, let's see, 1.5 inches, and then we'll have to make a washer. So my mill is a Morse taper number 5, which is what this is here. So we'll have to turn a taper, and then once that is done, I think we'll put it in the Inco, because it's a Morse taper number 5 taper in the headstock, so we can put it in there, and then we can do basically these features here. Obviously this is R8, but just use this as an example. So, and what they did is they milled out, and looks like these are pressed in drive dogs, and these are actually just inserted, held in with a cap screw. So should be a lot of turning, and then of course at the very end, I guess we'll mill the tang. So let me go outside to my storage locker and see what kind of material I got. Hopefully I got something, because I'm gonna have to start off with something that's about 3 inches obviously in diameter, or for you guys that do metric, what would that be, like 300 millimeters? And then take it down to 1.5 inches. So basically we got to take off half the stock, but that way we at least got a good face going against this face. So let me see what I got, and I'll be back, guys. Well, saw time is playtime. Pew! So you saw me load this up. This is a scrapyard score. This is a 4-foot section of 8620, and it is 2 3/4 inch diameter. If I remember right, it's just shy of 3 inches. Yeah, I didn't have a 3-inch piece and I didn't feel like ordering it, so. But yeah, like 50 cents a pound at the scrapyard, so it probably cost me 20 bucks. You imagine how expensive this thing would be if I ordered it from a master car? Probably, what, $300-400 easily? So that was a good score. Every now and then you got lucky down at the old metal recycler scrapyard place. I miss that. Oh yeah, I'm not doing my due diligence here. Alright, buddy. You gotta drop it. You know how the game's played. Of course. Alrighty, here we go. This should make a good arbor, good quality stuff. I was looking for some 1045 or even some 4140, but heck, this'll work. I've had it for, geez, ever. Probably had it about 6-7 years. Finally got a project for it. All set up over here at the jet lathe. So we got her dialed in. Surface is a smidgen rough, so I got like what, 2 thou that I can't. I don't know, you guys see that? Yeah, you're getting blown out anyway. So, not gonna worry with that. Gotta do it over here because we got 6 inches of taper we gotta cut, and compound on the Monarch and the compound on the Inco doesn't have that much travel. Thank goodness this compound does. So I'll get this faced, center drilled. We'll get a center in it. You know, I got to set up my angle, and then we can just whittle down all that material. To help set up my angle and make life easy, I'm going to be using Jim's lathe compound sign bar. This is a 4-incher. Jim makes some awesome products over there at Tangent Engineering, if you're interested in one. So this is the kit that comes from him. Look at that awesome thing. So for those that haven't seen this, so from this pin to this pin is exactly 4 inches on the money. And then Jim has also upgraded his kit, so you get a bunch of these cards. Let me see that, we're getting washed out. Let me see if that's any better. You guys can read that. So you get several of these. One's got the Brown and Sharp taper, Jacob's taper, Jarno. This one's the Morris tapers. So it gives you all the information. You don't have to go over to your machinery's handbook and look it up. So we're doing number 5. So it gives us the ending diameter, the starting diameter there, the small diameter, and the length of the taper for foot. And then also for a 4-inch sign bar we're using, we need 0.10521 if you wanted to try to do that in a gauge block stack. But what he has done is he has made these. I believe these come in the kit now. So these are precision ground exactly to the height that you need for the taper that you're going to cut. So you don't have to try to do your gauge block stack. So see, that's a Morris taper number 1, so probably all the way to the bottom. Need to go to the top. So there's a 4, 6. Where's my number 5? There's number 5. So we'll be using this one right here. If you guys can read that. So that'll go behind one of the pins, and that'll give me the correct angle. Put a gauge on her, we'll run her back and forth, and we'll get her straight. There, I'm trying to get the glare off the glass there so you can see. So after quite a bit of fiddling, I finally got it. I mean, it moves just a smidgen, but that's as close as I can get it, because as soon as I tighten it down, it moves. So I've been fighting it back and forth for a good 30-40 minutes, but we're finally there, I believe. I got it locked down, so happy with that. So I'm going to whittle down this section here to the major diameter of the taper, which is basically got to remove 1 inch. Well, you guys saw me previous clip indicating off this 4-inch sign bar I got from Jim at Tangent Engineering. Talking to Jim about it, and he was like, well, you're really kind of pushing your limits because the taper is over 5 inches. You really should be using a 5-inch sign bar or a 6-inch sign bar. And I told him, you know, I kind of was thinking on those lines. So, you know, I had tried originally extending this surface here, say with like a parallel, so I'd have it. I don't know about you guys, but I went through all my parallels and none of them are precision flat. Obviously they're not made that way. They're made to be, you know, ground. So, you know, this dimension is the same as this dimension and there should be a matched pair, right? You know, but you're hoping that, you know, hey, maybe I can get away with it, but none of mine are flat. This is actually made in Taiwan, not, you know, the rest of them are economy. And I don't know if you can see the slight bend in them from using them. So I took all my parallels, put them on the surface plate, you know, was checking them. Some you could actually rock, and the ones you couldn't rock, you could see light under. So, you know, there's probably at least 1 thou, maybe 1.5 thou off. So, you know, if I try to use that and indicate off of it, you know, that's a lot. When you're cutting a taper, it would really throw my taper off. So, shout out to Jim at Tangent Engineering. He's like, hey Tom, I got you. And what did he do? Well, my man sent me out a 6-inch sign bar. So, talk about an awesome company. You guys need to support Jim and his products. Of course, the products speak for themselves. They're really awesome, but talk about, you know, pick up the phone and call and talk to the guy and you know, he will answer any questions. But so I got a 6-inch sign bar, so I'm gonna set this up and indicate now, so make sure we get this taper exactly right, especially since I do not have a Morse Taper 5 sleeve to test that on. And of course I've been working on another project because you know why? I have been waiting on this. Man, what a nightmare. So, you know, to set up that 6-inch sign bar, say that 3 times real fast, I need a gauge block stack of 0.15782. So with my gauge blocks, I was able to, you know, I got a 0.1008, but I couldn't make up that 57 thousandths. And usually, you know, I can get away with some sort of combination or, you know, using small little drill bits. But I couldn't get there. I needed a number 57. My gauge block, or should I say my gauge pin set, goes from 61 thousandths up to 1 inch. I never had the smallest one, which is what this is in here, that goes from 11 thousandths to 60. Ordered this baby. And instead of getting in 4 or 5 days, you know, the USPS decided to send this all around the United States. I could see tracking going over here and going over there. Then they missent it over to Kentucky. So finally, like about 12 days later, I've got this, so I can film this, and we can get this set up, and we can cut a taper. So, man, you know, some days it's you know, you're the bug, and some days you're the windshield. So let me get the camera over here and get you guys ready to cut this taper. I'm not going to show indicating the 6-inch sign bar. You've already seen me do the 4-inch, so I don't need to repeat that. But let's get making some chips. Well, hopefully you guys can see that. It's not getting washed out. But we are good to go. I know you're not moving with it there, but it's the best place I can get you. So, how's that? Better? Maybe. If I hold my hand there and move all the way back. Probably losing it. But we're dialed in. You just saw me reduce this area down here. This is the tang. So we are basically ready to start cutting that taper. So it'll be long and boring. So we are basically there. We're a few thou large. I got a TNGG insert in, so I'm hoping to make a nice pass or two and get a good surface finish. This is kind of rough. Unfortunately, this hand wheel on this compound isn't conducive to nice, smooth rotations. It's kind of clunky and cranky, so and I'm struggling with that. There's your 0. 1660. Go a tad more. 167. Alright, see, she'll clean up. Nice and slow. Well, it looks a lot better than it did. It feels a lot smoother than it looks. Maybe with a little bit of emery or some Scotch-Brite should clean up nicely. Didn't help that the chips wanted to sit up here and scratch it after the fact. Somebody got a new football today. Come on. You gotta drop the thing, I can throw it. Put it down, you know how to play. He's gonna be possessive of it. Well, as soon as I say that. Alright. We're going long, you ready? There you go, good boy. You drop it over here for me? So I can sit down and eat lunch. Well, let's see how we did. So I just cleaned the bore out here. If you feel down in there, my finger will hit it where it stops on the taper. So they've only cut about, what's that? Like a 3-inch taper. So we won't get any measurements here for this couple inches right there. See if this Prussian blue is still good. Or if it's, oh nice. I know just a little will do you. I got one shot at this anyway, so if it ain't right, then ain't like we can put it in, get it dialed back in. So let's hope for the best, right? Well, it's pretty good. All right, let me get it out. And the lathe is in gear, so that's good at least. Alright, so you can see where it's sat. I got contact all in there, all around there where I rotated, so I got a fair amount, at least in the area that it is cut the taper. So cool, that's good, that should work. All right, happy with that. So now what I think I want to do is to Go ahead and cut the tang and cut the slot for the taper lock key, because we still got real estate here I can grab a hold of. If we machined all this and did those two operations the last, I really don't have much to grab onto. So I think that's going to be the plan of attack. So let me get that set up. Okay, here's the setup to basically get that tang cut. Got a 1-inch fine rougher. Really you need about 1 1/4 to get the exact radius of the other tooling, but I think this is close enough, so it'll be fine. I don't think we're going to have an issue. I don't think it's going to move, but just in case, I got an indicator over there to let me know. So let's get some chips going. You guys see that from there? So I am about 26 thou large on each side, and you can see those lines that were left from the fine rougher. So got a regular 4-fluter in here. This is a regrind. Picked a whole bunch of these up off of eBay in a group lot, so they're all USA made. We'll give her a shot and get it cleaned up to our final dimension. Well, it came out pretty good. I missed my measurement by a few thou, but it's a few thou smaller, so that's not a problem. And then the setup, I couldn't get all the way into this radius because of the toe clamp. Using a, that 4-fluter, the end mill holder was going. I got it like just a couple thou away from that toe clamp before it hit it, so I couldn't get all the way in this radius to get it cleaned up. So I got a little bit of roughness from the rougher. But anyways, I think it came out pretty good. So now I can go over there and stick her in the HBM spindle and get a location for that slot for the taper lock key. Set up to cut the hole now for the taper lock key. Just went over there and seated this in the spindle and then traced it out with the magic marker. That should get us pretty close for this, what we're doing. So we're already still centered up. I didn't do anything with the DRO, so that made life easy. 1/2-inch pocket. I've got a 1/2-inch end mill. I'm just gonna go down, level this out, and then I'm gonna drill all that material out of there, and then come back with the end mill and just clean the pocket up that we make from drilling. So pretty easy operation. Just finished up. Pocket came out nice. I'm gonna let it cool down a little bit because I know it's scorching hot. I didn't want to run mist coolant because I wanted to kind of see what I was doing. So once it cools down, I'll get it out and deburr it, and then we'll get it over to, I guess, the Inco. Well, it's starting to kind of look like an arbor. So slot came out nice. There's the taper lock key. Got a good snug fit in there. Actually, just enough so she slides. A couple thou, clearance there. But I think we're good there. So now what we need to do is turn down the features we need here. Taking it down to size now. Took an OD skim pass. Got about 165 thou to come off to get to the right length. Well, I just saw there was something on the lens, so I hope those last two video clips, it's not too bad. Anyhow, let's see, we got to take some material off of this now. We got to go in basically 1.5 inches, and the diameter's got to come down to, well, actually diameter's got to come down 1.5 inches. We're going down just shy of 1.5 inches, probably about 1.485 or so. That way I know it's just a bit shy or just a little bit under, so when the face mill goes on, put the washer on, she'll pull up. I don't want it to bottom out on the washer because then it wouldn't pull up tight. So got the mist cooler set up, and we're just going to choose some material. So here we go. Take a more aggressive cut than the shits ain't bragging. I'll speed the feed rate up too. Is better. Increase the feed rate and the depth of cut. Still gonna be stringy. May need to change different inserts. That ain't gonna work. Breaking now. Here we go. Look out. Close your eyes and put your safety squints on. Ooh, they were hot. Gosh. Alright, we should be there, but I think we're a smidgen large. I don't know if you can see that. We are, well, 9/10 large. So, alrighty, let me just take a little bit of paper to it and get it down, and it should slide right on. Let me get my gloves off. Small fingertips. Said don't need much. Oh man, she wants to go. Still a smidgen large. Alright, let me work on it. Think I got her. Ha ha. Sweet. Man, you couldn't ask for a better fit. I don't know if you guys can see that down there. So this is what I was talking about. I wanted to be just a little bit under, basically have the face mill proud. So that'd be good. So it should lock up nice and tight. So, all right, that looks good. So now what we got to do, we got to put a hole and thread it. We'll have to make a washer. And then lastly, we got to, you know, mill this slot out here and put a couple dogs in, and this thing will be ready to go. Seven 16/14 TPI tap. Just inch her in. Yep. All right, I'll do it by hand. Got a chunk of Mr. Steel in here, 2 1/4 inch diameter. Got to take it down to about 2 inch and about 200, so about 50 thou to take off. Will just make us a quick washer. making good progress. We're basically on the home stretch. So you saw me knock out the washer. So got a good fit in that hole right there. Got to get it lined up just right so she'll go in. There you go. See if I can keep this in frame. And then this bolts down and holds her together. I need a bottoming tap. I need about an extra thread and a half, and she'd lock in there, because right now she's not locking in. You can see, I mean, it's about there, but I need a smidgen more, so I have to order a bottoming tap. But all we got left now is to mill out the holes to put the dogs in. This is a 5/8 key, so it'll go in there. So let me get this set up in the milling machine and we'll get these knocked out. All set up to cut the slots for the key stock. I think we'll be good. Got a 1/2 inch cutter in there. I'm using 5/8 key stock, so we'll come over to our to the depth, basically on our x-axis, or should I say the travel, not really the depth. And then we'll just keep going down, whittling away. We'll probably take that and then move over, obviously, so I get 5/8 width, and then I'm thinking about 1/2 inch depth. So, you know, nothing rocket science here. Should be at our depth now. Alright. You guys probably can't see that. Hang on, let me move you. I mean, this wasn't critical. It's just a nominal depth. I just picked 500 thousandths. So that looks good. So now I just need to do is move over each way so I get 625 thou slot. After some fiddling and taking it back and forth just a little more, because apparently this cutter is a few thou under 1/2 inch. So this is a 625 gauge pin. So yeah, got a good fit. So happy with that. I think what I'm gonna do now, here's the key, is go ahead and round it and get it in there where I want it, since we're all lined up, and then drill the through hole through this, you know, and then the tap drill size to that. Over here at the dual bandsaw, so just laid it out, made quick work on the belt sander. So now I'm just going to cut it off to length. Cut some wood earlier so you can see all the sawdust. Well, one is done. I think it came out pretty good. I didn't film, you know, drilling it and counterboring it and all that and kind of holding it and doing some real sketchy setups. So, yeah, but we're good. So now all I gotta do is just rotate at 180 and rinse and repeat. Looks like it's running pretty true. Alright, I'll take that as a win. It is all wrapped up. One Morse taper number 5 arbor for a nice big carbide insert face mill. I think it came out about as well as can be expected. So a lot of milling and lathe work. So if you come to my channel for a machining fix, this video ought to do it for you. So the reason why we did this is because next week's video, we need this. So you know how projects lead into projects. So this got bumped up on the list. So yeah, sweet. We are good to go now. So I hope you guys enjoyed that video. Next week should be fun. I've had this material sitting on a pallet for about 2 months now. So glad to finally get to it. And welcome all my new subscribers to the channel. I appreciate you. Hope you hang out and enjoy the videos. And of course, you know, I love all my old subscribers. You guys rock. As always, leave comments down below. Thumbs up are always appreciated. Go check out Tangent Engineering's products. You can even call the phone number and Jim will pick the phone up and you can talk to him directly. So, you know, that's what's great about his company. So he can answer any questions that you might have. And we'll catch you next week, guys. All right, see ya. Bye.